No, just that section. So guys, a lot of you guys got homework back from me earlier. So if I said like 1-1 correct, 1-2 okay, 1-3 correct, you don't have to do anything with 1-2. Even if you got some wrong, you didn't get enough wrong to make me worried. The ones that I said correct on, those sections you currently have half credit. If you make corrections, get enough of those corrections right, you can get back up to full credit. Is that cool? All right, so if I say okay, that means you're good. That means you're still at full credit. If I say correct, you're at half credit. You can stay there if you want to. Or you can make corrections, and if you get enough corrections right, you're back up to full credit. Does that make sense? Yes.
So if you're correct, is you like
okay. Yes. Never change the original of any corrections. If you correct a quiz, you can correct these quizzes when I get them back to you. You can correct the homework. Don't erase and change anything on the original. On another sheet of paper, or if there's room and you can make it clear, you can make corrections next to the problem. Is that cool? If you're not sure what you did wrong, then that's maybe why I have office hours, and maybe why we have tutors, and we pay them, and they help people. So that's a good place to go. Office hours, tutoring center, it's crazy how much help there is. You're not expected to do this completely by yourself. That would be insane. So you can get help on corrections. It's beautiful. Homework corrections are due on the day of the final. You have a ton of time on homework correction. You do them whenever you get time. Quiz and test corrections are always due the day of the next test. Yes?
How does the test corrections work? Like if you...
So quiz corrections and test corrections work the same way. If you get an 80 or below, you can get 5 points back maximum if you do all the corrections and get them all right. So if you get an 81, you can get up to an 86. If you get a 97, you can get up to 100. You can only get up to 100.
So if you do test corrections for both quizzes and tests?
Yes. And if you get below an 80, you can get 1 point back for every 4 points you missed if you do all the corrections and get them all right. So if you got a 68, how many points did you miss? 32. Divided by 4 is 8. You can get 8 points back up to 76 if you do all the corrections and get them all right. Don't do 8 points worth of corrections, because then you'll get a little bit back, right? If you get a correction wrong or you don't do a correction, the amount of points they give you back goes down pretty quickly. You'll never get less than what you had in the first place. Even if I'm like, oh, I forgot to take points off, I'm not going to do that. Nobody would give me corrections then. I wouldn't blame you. So you'll never get below what you got. You with me? You can only stay the same or go up.
Do we only get one correction at a time?
No, you can correct everything. Now, make sure you understand what I mean. You can only correct something once, but you can correct everything. So you can make corrections to quiz 1, quiz 2, quiz 2. But you can only make test 1, test 2, test 3. Not the final, because that's appropriately named. Final, right? But you only get one chance on each. It's not like English. It's not a first draft, second draft correct. No, screw that. It's enough already in grading the thing twice. All right. You're welcome, by the way. No, none of my teachers did corrections. Shit. I wish. So the people that don't do corrections, I don't understand you. You don't make any sense to me. But you're right. You don't have to do corrections. You don't have to vote. Yes?
So if you fail the quiz, you can only get it up to a C.
Which is great. It's better than the grade you had in the first place. Right? I'm sorry. If you don't like it, I can give no points. Oh, okay. Ooh, look at you. You perked right up. I can only get up to, well, shit, man, you can get up beyond what you had. Please, dear God, enjoy that. My whole purpose of that is the grades shouldn't be static. They should follow your understanding. And there's a whole other level of corrections. If you do all the corrections, get them all right, and you get a higher grade on your test, your quiz grade becomes your test grade. Good God, man. I mean, good God. What more can I do? Not much. It's still, what I like about that is it's still on you to make the grade. It's still on you to get the corrections right, but it's still a great opportunity. All right, maybe. I don't know why some of you guys look so downcast. This is freaking awesome. Shit. Okay. All right, so what I want to do is, well, first off, any questions from homework stuff that I didn't cover yet? Anything left over from homework? Yes?
Section 2.4, number 86.
Oh, yeah, good. I like this problem. I would like to describe one. Oh, there it is. That did a lot. All right, that's pretty good. So this is the problem looks familiar? No? Shit. So it's saying in a survey of 20-year-olds in China, Germany, and the United States, people were asked the number of countries they've visited in a lifetime. The following box plots display the results. So a really good question is, what the hell's going on with China? What's it missing? The box. I love it. But the freaky thing is, if your data has a lot of repeats, like your data is, I visited 2 countries, and we visited 5 countries. Low, Q1, Q3 high. So the low in the Q1 and the high in the Q3 could be the same. Do you guys see that? Do you guys get the idea? So when I go to make my 2, 3, 4, 5, I put a line, and then I put a line at Q1, and then I put a line at Q3, and then I put a line at the high, and that's how you could have no box. If there's repeats, if there's a lot of repeats in your data, you can actually have a box plot without a box. All right. Okay, cool. The little dashed line means what?
50.
I mean, what's in the middle of the box in the box plot? Q2, the median, right? And here the United States doesn't have a whisker on this side because it's sort of like the same. It's the low and the Q1 are the same. You guys get that piece? So that piece is weird. When you first look at it, you're like, what the hell happened? But that's what happened. It just has some repeats. So they ask you stuff like, describe what the shape of each box implies about the distribution collected. So I already gave you one. China must look something like that. And China, I can be more specific. China must look like 0, 0, and, you know, I got the 5 right, just got the 0 wrong. You guys kind of with me? Does that make sense? I mean, and now tell me what this distribution looks like. Tell me what this distribution looks like. Give me some idea of what the data kind of looks like. You can tell me that most of the data is here, whatever. There's a lot of different answers that I'll take. It's just show me that you understand what this thing is trying to tell you. Okay. Who asked this question? What was any specific question about it?
I was just confused about the China having no box.
Oh, okay. I love it. He's answering my question. I'll just take whatever else he does to say.
Repeat the dotted line again one more time.
Oh, so the dotted line says none of these look traditional. The dotted line, this is Q1, Q2, Q3. This is the median. They just make it a dotted line for some reason.
Or Germany.
What about Germany? So therefore Q2 must equal Q3. That's all that means. Does that make sense? So now you understand that. Now it makes sense why it doesn't look like what we're used to. It's just because there's a lot of repeats. A lot of people said 8 countries. So there's a lot. So these two just happen to be the same number when you count through the data. Do you guys get that? Yes? Maybe? No? Okay? Yes? I like it. Got a thumbs up, so that's all I need. I'm feeling good. Shit. Those of you playing at home, that's what we were just talking about over there. That problem. All right. All right, anything else from homework? Yeah.
It's 90 the same section.
Constructive box plot. I like it. So they've already told you now that the problem with this is that they're telling you there's 5 zeros and 9 ones. So how many total data points are there? 25, right? Add these up, get the total number of data points. How would I find Q1? What's Q1? What's another name for Q1?
35%.
Who do what?
25.
Yeah, 25th percentile. I like it. There's 25 data points. How do I find the 25th percentile? Take 25% of 25. 6.25, believe it or not. If you don't believe, just type it in count. Round it up. No, I gave it away, but what do you do with that? Round it up to. The 7th number will be the answer. Now watch. The 5th number is 0, so the 7th number is 1. Careful, there's 9 ones. You guys see it? Or if you want to, you can write 5 zeros and 9 ones and make it a big list so you can count into it. But that's really all this is. I go in 5 and 0, 6, 7, 8. There you go. Q1 is 1. They just collected all the repeats for me. That's all they did. So you can recover the list if you want to and write 25 numbers out. It's not bad. So you can count in. Or you can realize I can just count in the way it's given. Okay. So again, you might have some repeats. So you might not get, like, the box might be missing or whatever. Okay. Anything else from homework stuff? Oh, yeah. Somebody nice, people at home. I'm not nice, but somebody nice showed you. Okay, that's the one we're working on. I should just keep it there, shouldn't I? Too bad. All right. So that's it? That's all the questions for right now? Yes?
So we're supposed to be done with both chapter 1 and 2 before the test, right?
Yeah, by the day of the test, you should be able to turn in through section 2.7. We got into 2.7 last time. Today we're going to finish it out. Yeah, I'm going to give out the practice. In fact, while I'm saying it, I might as well do it because I know me, I'll probably forget. Here's the practice test. Real quick thing about the practice test. You do not have to do this at all if you don't want to. Don't turn this in. I'm going to give you the answer key. This is not exactly the way the test is going to be, but all the concepts on here could show up on the test. Holy shit, that's a very teacher thing to say. But that's what I am. Yeah, exactly. The main reason I do this is so you see the format that I use. So the format's going to be like this. I'll actually give you room on the actual test. Right? This is a practice test, unlike saving time. Townsville, yes. The people of Townsville. You know where that's from, do you? Yes? Okay. Alright, got enough of those. Yay. Alright guys, so if you were not here last time, I feel bad for you. You should probably go watch the video. Because last time we actually created, well, that was a magic trick. Holy shit. I was like, do it again, Jeff. Last time we created the equation for something. What was it we created the equation for? Standard deviation. I like it. So just a very, very, very quick rundown of the idea. If I get some data, and I take the difference between the data and the average. So for example, this data point was 4 and the average was 9, then this would be -5 then. Blah, 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 blah. What will this column always add up to be? Unless you round it a little bit. It should come out to be what? The sum of these should always be at least close to. You can do it. There's a whole problem with this. This is why we had to do the next thing. The mean is the number that's in the middle according to the value. So there will be equal amounts above it as below it. So when I add all these up, equal amounts negatives and positives, it's going to add up to be 0. As above, so below. So the problem then is, everything's frickin' 0. That's stupid. I want this number to differentiate between data sets. I can't use this shit then. So what I do is, we had a little discussion about why we don't use absolute value, because that would take the negative off. So the next best thing is squaring it. That would make all the negatives go away. You just have to remember at the very end we have to square root it to kill those squares. If these are dogs, 4 dogs, 5 dogs, 6 dogs, I don't want square dogs running around. right? That's weird. A little cube, I don't know. It's horrible, Jeff. I'm thinking trash compacted dog, poor little dogs. That'd be 25, blah, 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 blah. So the idea of this number that we are creating, I really desperately hope that some of you guys realize we are using math to do something we need done. I mean, that's how math, there's all these tools math teaches you, that's algebra. And then you go, now we got all these freaking tools. Might as well use them. Holy shit. I want a number that will tell me the average distance from the mean. So how do I do that? I take all the distances from the mean, I add them up, and divide by how many there are. Right? That's how I get an average anything. It's squared, but I'm going to have to take a square root, but it's basically the idea. Oh, shoot. That's my bad. What symbol should I use here? Because this is all about population. I don't know if I remember. Mu, yeah, the French cow. Good. Mu. 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 M-U. Mu. Right. Divided by n. Anybody remember the name of this guy was? This is before he took a square root. Anybody remember the name of that guy was? Variance. I love it. That name kind of makes sense because it's a measure of how much it varies in a way. And then if I take a square root, that is the standard deviation. So if you weren't here last time, I highly recommend you watch that video. It's huge. Standard deviation is remarkably important. What I desperately hope some of you guys see is, if I do this to something, if I do this, add them up, divide by how many, that's the average of that. So that's the average squared distance, and then I take the square root. So this is a measure of how far the data points get away from the middle on average. That is the spread. That just makes so much sense. Okay, cool. So this is all for a what? I got Greek letters going on here. So that is for a population. So if I have a sample, there is one thing that changes. And let me see if you guys can get this. This is neat. All right, here's my best attempt. I'm going to do this and then one other little math thing, and then I'm going to throw up there what the formula is. Right now there's an average age in here, right? There just is. There is an average age. You with me? You with me? Okay. If I selected a row of people, would their average age be the same as the average age of everybody? No. Now here's the trick. Here's the step you got to take with me. If I took you guys and found an average age for you guys, would all of you guys be closer to your average age or closer to the actual average age? They would be closer to their own. It only makes sense because that average is the one that's from them. So if I take a sample, the spread of the data will always be smaller than it really should be. Does everybody understand that? This is cool. This is cool. Therefore, I have to kind of make it bigger for it to make sense. So when I take a sample, I don't know the real information. I just know the sample information. And the sample information, well, I got to be careful, will almost always be smaller than what the standard deviation should be for the whole population. Let me just stop right there. Even if you don't quite follow me, it's okay. It's not absolutely necessary, but it would be so nice. Because what we do, if I'm talking about a sample, here's the difference. I got a little handout that's got all this stuff on it, so don't freak out. Or, freak out a little bit, but not a lot. So if I got a sample, this is all for a population. The only difference is this. First off, I don't use a Greek letter. Greek letters are for, population. And I use S, or R letters. So here, this is when I use X bar. But here's the trick. If this is too small, right? Because they're closer to their own average, so it's too small. Do I want to divide by a bigger number or a smaller number to make it bigger in the end? Smaller. So I actually divide by that. That is the adjustment because it's a sample. Yeah, and then, so this is the sample variance. So this is the sample standard deviation. Right? Right, just take a square root. All right, let me let you absorb that for a minute. This is related to, obviously, hopefully you guys understand, there's a lot more behind why this works specifically. But just the concept that I want to divide by less so this becomes bigger, so it's a better approximation for the real standard deviation, that by itself hopefully makes some sense. If it doesn't at all, don't freak out yet. This also has other significance. If I told you, now go with me, stuff. Oh, by the way, when we do a test, you can use a formula sheet. So one thing we do on the review day is we talk about all the formulas that could be on your sheet. If you have any formulas on there that I didn't say could be, you could lose points. And that's a silly place to lose points on your formula sheet because you can't correct that. So don't be doing that. So here's the other thing that this n-1 relates to. This is going to become really, really big later this semester. Go with me here for a minute. You're like, that's all we do, man. If I told you that 3 numbers average to be 10, do you know anything about the numbers? There's actually one thing you know. You don't know what any of the numbers are.
There's 3 of them.
True, there's 3 of them. I like that. And they're numbers. If 3 numbers average to be 10, what must they add to be? 30. Because 30 divided by 3 is 10, right? So at least I know the sum to be 30. That's all I know, though. So one of them could be a billion, as long as another one is like negative a billion, and then the last one is 30. Then the average of those is 10. Yay! You guys see how extreme it can get? But so how much freedom do I have in choosing numbers? Where did I have to start to be careful? If I say, let me let the first one be 17, do I have to be careful yet?
Yeah.
Not really. I can make the second one be anything. If I make the second one 8, what would the third one have to be? Let me see if you guys are really, really with me. The third one have to be 5. Because then 17, 8, and 5 makes 30. If I make the second one 11, what's this one got to be? 2. Because 17 plus 9 plus 2. So do you see what I'm saying? I can make the second one anything I want to be, but the last one then, I got no choice. So how much freedom, how many degrees of freedom would you say I have? Do I have all 3 degrees of freedom? Or how much freedom do I have? 2. So how many data points are there? 3. How much freedom did I have?
2.
Oh, 1 less. Oh, shit. Now, that doesn't explain. Now, don't get me wrong. I mean, I like the reaction. But that doesn't explain why it works here, but this is called degrees of freedom. And it becomes huge in, like, chapter 7, for example. And right now, it's there because it's there. All right, that's as deep as I'm going to get into it, because to really get into this, you need a little more math than a lot of you have. So this is plenty. Just think of this as the adjustment because it's a sample, not the whole population, right? So let me give you this handout, and I want you guys to work on this together, or alone if you really don't like other people. You're like the first guy at the light, right? It changed. What the hell's wrong? Maybe it's just me. So I give this to you. I'll explain a little bit about this. Is 2-sided. One side is all filled in. A nice example. And the other side is for you to do. Because I got tired. Do the rest, hopefully. Can I just borrow yours for a second? Alright guys, so here, Oh, I forgot about that. Shoot. Let me do this with you real quick. This is a little bit weird right now. So let me show you this. It's going to help you out quite a bit. If you have a calculator, you can try this on your own. If you don't, just watch. Let me try this. This is why they took the remote control away, by the way. They have like things up here now. Let's see how this works. Not at all. All right, good. All right, they're still working on that. All right, that works better. Give me the computer. Do it. Give me the computer. Oh, shoot. I mean what do you call it? All right. All right, so real quick, guys. We looked at this already, the lists. Right, we looked in here, haven't we not? Yes, we did. So everybody see how I got there? And again, the calculator Bible is up on the website. There's the calculator guide. It has all the instructions for everything we're going to be doing in the calculator this semester. Just to show you real quick. There it is. Sure. So it starts with just basics about how to use the calculator, period, and then it gets into data, into the lists and stuff like that. Okay, so it's up there. You can print one out if you want to. You can come to my office if you want me to print you one out. It's all right. So if you have any data in your lists, you go up and you hit clear, enter. Don't hit delete, because then it's going to make the list go away, and that's bad. All right, so is everybody who wants to be following along with me good so far? Okay. So now if you put the data in, 1, 2, 5, 8, 9, right, from the sheet? 1, 2, 5. Does everybody see me what I'm doing? I'm just doing the front side because I want you guys to do the back side yourselves. Right? 1, 2, 5, 8, 9. Now the next column, now what is it I just put in there? What are those? What are those? What are those? It's kind of old, but what is it? What is it? What are those? Yes, and so it's if you're doing it on your paper, what's at the top of the column? We just did it a second ago. X, right? Those are my x's. Those are my variables, right? The variables, the values of the variable. Those are x's. Are you with me? So on the paper, if you look above list 1, see where it says list 1? What's it say right above it? Holy shit! Okay, good. All right. So those are the x's. And then what's the next thing we do? X minus x bar. And what's the average of 1, 2, 5, 8, 9? Well, you just take the average, and you get 5. So over here in L2, now watch. Go up to L2. And now let's see how at the bottom it says L2 equals what? So you're going to say L2 is L1. All the stuff in L1. See how I just did L1? Second 1. Second 1 for L1. What's that do for us? Ooh, look at that. You guys semi with me here? Second 1 is L1. You guys see that? Minus 5. So that means x minus x bar. Because x bar is 5. And now if you enter, it does them all at once. So you can imagine this is going to help you out when you have a longer list of data. This will be really nice to do it very quickly. And then L3, I'm going to just do what with those? Yeah, if I try to put it here, this is the error you get. If I try to put L2 squared here, it's like, okay, dude, you're trying to put a whole list into one spot. It's going to go data type. What the hell, man? So you say go to, and you're like, oh shit, I'm sorry, dude. All right, anyway. Go up to L3. L3 is L2 squared. And then I'll just fill in the whole L3. And those are the same numbers you see on the sheet, right? So you don't have to do that. But for a longer list of data, I would highly recommend having the calculator do all the freaking squaring and subtracting. That's Math 88. You've left that in the dust. I'm not going to grade you on that. All right, so you guys work on the back side. I'm not going to say a damn thing about the questions. I'm going to let you figure those out yourselves. stat set of it. Whenever something like that happens, and then you go back in. Yeah. Sure.
I got a little bit confused on what you said that L2 was. I mean, it's supposed to be the mean, right?
Well,
I mean,
X bar if
X
it's a sample.
minus-
Yeah. X bar if it's a sample. So, but the mean was 5. If you add, take the average of those is 5. So then you would say L1 minus 5 because you want all the X's.
Oh, and
L1, second one. See where the L1 is right there.
oh,
Second one minus 5.
yeah.
Yeah, because you want all the X's. That's L1 is where the X's are.
Okay. My L1 is
Oh, it's stat set up that for some freaky happens. Now if you go back in and tweak stat at